Welcome back. Let's continue creating our isometric game. I want to start with something that was asked in the comments. One of the comments was, why do you use an SE simulator to show how the game works? And my reasoning was, well, that's the smallest device Apple currently sells. So it will give a good idea about what it would look like for at least if you have very little screen real estate, assuming that if you choose a bigger device that it would work even better. But that is an assumption that we need to check. So I'm first going to run it on the iPhone SE. And sure enough, this looks okay. So how about a bigger device? So let's choose something like iPhone 15. So let's run it again, see what happens. So the assumption is that this works more or less out of the box. However, now the buttons are in kind of an inconvenient place because this is where you would normally drag the screen up, as these devices don't have a dedicated home button. So it would be good to fix this, and the easiest solution is simply to add some padding to the V-stack. So let's give it another go. So now it's nice and above this draw bar. So that's the first thing I wanted to get out of the way today. But what I really want to do is add a sprite that we can animate on the screen. So I really want to do some animations in SpriteKit. And to do that, well, let's get some animations. And I've uploaded some some sprites. I'll put the link in the description below. So we have a couple of sprites here. Let's quickly create a folder for them. So we call this the night, and we drag and drop all these animations in. So these are all 2x animations, and they're basically four frames per direction. So there's one for looking in the northeast direction. There's one for looking in the northwest direction. There's one for the southwest direction, and there's four more for the southeast direction. This is just the idle animation. In the next episode, I'll quickly show how we create these these sprites. But for now, let's just assume we have them. Also note that depending on how many frames you want per per animation, and how many animations you have, and how many types of entities you have, the amount of sprites grows pretty big. But that's a problem for another time. So let's see if we can add, for instance, the night to the screen. So let's go into a game scene very quickly, and we have our redraw function, and let's just start by hard placing a sprite on the screen. So let's create a night as an SK sprite node for an image named. And what we can do is we can just pick and choose one. So let's choose one where we're looking at least somewhat into the camera, like this one. So we'll copy paste this file name, paste it in. Then we need to make sure that the night has the correct position. So let's create a night screen position, and this will be a controlled world to screen for position. And let's assume that our night is at let's see, how about at 1 1 1 1 So we can pass in the night position. We also can then assign this to the night screen position, and we can do something similar for the Z position. Oh, we need to convert the night screen position to CG float. This is .x, and the night screen position .y. And we have the Z position, that's a CG float. We convert the world to Z position for position. Let's see, so this is, I'm sorry, we use the night position, and as a direction we can use the rotation of the scene. And we need to add it to the screen. We need to add it to the root node as a child, so we add the night, and let's see if this works. So now our night is indeed on the screen. Perhaps it's a good idea to zoom in a bit. We can do that by setting the scale for the camera to a half. That is like zooming in by a factor of 2. So everything's a bit bigger now. And what we can see is that the bottom of the night is exactly lining up with the bottom of this of the tile. And in my opinion, that doesn't look so good. So what I would like is the night to be a bit higher on the y-axis, just to give it a bit better feel that it's standing on top of the tile instead of between tiles. We can do that by changing the night's anchor. And this is, I think, a CG point. We can still use the middle, and I think we can use something like 0.4. Typically, this is a matter of trial and error to find a reasonable value. So this seems like a reasonable value. The cool thing is we can still rotate, although it doesn't work correctly at this time. And the reason is we should also add in the direction here as well. So let's give it another go. So the night indeed moves along and stays on the correct position. Of course, it's not looking the right direction because it seems like it's changing its facing. So now it looks like it's in line with this row of hills, where as we rotate, it seems that it's somehow looking away from the row of hills. And now it's looking in the opposite direction of the row of hills. So that is something we will fix later. What I first want to do is get some animation running, because we still have a single static sprite. Well, what we need is a way of getting the animation from the assets that we passed in. So let's start with the simplest case. Let's create a function that gets a night idle animation and that returns an SK action, because that's how in SpriteKit animations are defined. So let's have something like frames, and the frames are the names of the images that we need. So we have a night, idle, and the 225, and the image name for the frame. And we have 4 of these. So we have 1, 2, and 3. And what we can do is we can convert these into textures. And we'll pass in the frame name. We can also pass in the frame and Make sure that the frame.filtering mode is set to nearest. This way, as you zoom in, you get that nice pixel art like chunky pixels without any fuzzy borders. So return the frame. And now we have a set of frames that is an array of textures. And this we can transform into an animation. What we can do is we can create first the animation. So we'll say we have the idle animation. That is an sk action.animation, an array of textures, of frames. And let's say we have 4 frames per second. Then we can return the new sk action repeats forever. This way we can make the idle animation run forever. So we now have get a function that returns the correct animation. So let's start using that. And we do that by simply saying we have our night run, and then the action get night idle animation. And let's see if this indeed makes it animate. Look, it's sort of animating, hopping in place. But still, as we rotate, it seems its facing is changing. And what I really want is that the night keeps looking in the same direction that it did before the rotation relative to the world. So it shouldn't rotate itself if we rotate the view around. So let's see what we need to do that. Well, let's create a test first. We're still working on rotations, and the first test will be that a rotation with a reference rotation. This is a new function we will create based on default rotation, always returns existing rotation. So basically this is not really rotating yet. So let's take a rotation in a couple of rotations. So we have 45 degrees, we have 135, we have 225, and we have 315. We will assert equal that if we have this rotation with reference rotation, and this is a function we still need to write, and if we pass in the default rotation, then we get the same rotation back. But of course this doesn't compile as this function doesn't yet exist, so let's create it in the ISO converter where we have the rotation. Let's create a function with reference rotation that takes in reference rotation and returns a new rotation. And for now we can just turn the default rotation. This at least makes this one pass. So let's run this one. So the test fails because we're hard coding a value back. However, if we just return ourselves, then this test should now pass. Okay, cool. But this isn't doing that much yet. What happens if we don't have the default rotation, actually have a rotated view? Let's have a look. So consider we have this map. We have this sprite looking in the 45-degree direction, and this is also our map's current location. If we rotate the map 90 degrees counterclockwise, the view will now look at, for the map, at 135, and the uh, unit we see here, the sprite, as well. And this also works the other way around. Let's say we have, this is our current rotation for the view, and we have a sprite looking out at 315. If we rotate 90 degrees clockwise, then we go to the 225 degrees rotation for the sprite, while the map is looking at the 350 location. And the generic form is that if we have a default rotation, basically the rotation representing no rotation, we have a look rotation, that's the direction the entity is facing. So in this case, that's 315. And we have a reference rotation, that's the rotation the map is pointing. Then the new rotation will be the look rotation plus the reference rotation minus the default rotation. And this makes you move around in multiples of 90 degrees. In code, this is slightly different. We can take the raw values of the look rotation, add the reference rotation, and remove the raw value of the default rotation, and take the modulus of 360, so we always get a value between 0 and 360, and use that to create a new rotation. So let's start using that by first creating a test. So let's create a test to test this new rotation transformation. So we have, again, test rotation with reference rotation, but this time we take the reference rotation into account. And we do, let's create some test cases. So let's say we have test cases, and test cases are an array of look rotation, reference rotation, and an resulting rotation. So we create a tuple that contains two input parameters, the look rotation and the reference rotation, and then returns a resulting rotation. And this is an array. And I'm going to copy paste this one in here because it takes a lot of time to type out, and it isn't difficult to determine because it's basically looking at a piece of paper and looking at the various cases that you find. So we have a lot of test cases now. Then we go over each test case in test cases, and we exert that if you have a test case look rotation and we rotate it by a reference rotation on the test case reference rotation, we get back the test case resulting rotation. And this test should fail because we haven't implemented the code yet for doing the actual conversion. So let's do that now. Let's go back a bit and return a rotation based on the raw value. And the raw value is the current rotation's raw value plus the reference rotation raw value minus the default rotation, and we take the modulus 360 and we unwrap this one because we know this will always work. This should be the raw value as well. So let's run the test again. and these now succeed. So let's go back into our game scene and start using these in our animation. So instead of getting hard coding the orientation back, what we'll do is we'll pass in a look rotation. Then we can use that one here. Can we use raw value there? So if we now, for instance, do look rotation something else, 45. If we run, we will notice that it's now pointing the other direction. So it's now looking into that direction, and when if we choose another one, let's say 315, we can now determine where it should look. But we're not yet taking the view into account, so let's start doing that as well. So we have the look rotation here. Let's create a view rotation, and that's the look rotation with reference rotation, and this will be the rotation of the of our own view. So then we can use this one, and I think that if we run this one, our knight will look into the direction relative to the map, regardless of how we rotate it. I want to go one step further and also show that you can independently rotate the knight. To do so, we need a variable to store the knight rotation. So let's say this is by default 45 degrees. And then we use this one here as a look rotation. And we should create functions to rotate the knight clockwise. That's a knight rotation rotated 90 degrees clockwise, and then we redraw. And that's something similar for counterclockwise. And go into our content view and create a couple of buttons to so we can rotate around. So let's create another H stack. Can copy paste this one. Call it rotate to knight. And counterclockwise. Let's see, this first one is counterclockwise and the second one is clockwise. Okay, let's run. So we have a second set of buttons that help us rotate the knight. You can still rotate the view and rotate the knight independently of that. One final thing I want to do is I want to make sure that we also use nearest neighbor. Let's see, the texture dot filtering mode should be nearest neighbor here as well, so the floor tiles are nice and chunky and crispy. So that's it for today. Next time I want to look at adding multiple knights or multiple sprites to the to our map. Thanks for watching and have a good day.